True or false? Number 1. The number of pivot columns of a matrix equals the dimension of its column space. That's true. That's the rank. This is how dimension of column space is defined or determined. A plane in R3 is a two-dimensional subspace of R3. A plane is two-dimensional for sure, but unless it passes through the origin, it's not a subspace, so it's false in general, false. Because a plane might not, this one is not, we are not given that this passes through the origin, so it's false. The dimension of the vector space P4 is 4, that's false. As you've seen, dimension of Pn, that's the nth polynomials up to degree n, that is n plus 1. In fact, the dimension of P4 is 5. If a set V1 through Vp spans a finite dimensional vector space, okay, this is span, and if T is a set of more than P vectors, so we have a T is got more than P vectors, so P1 all the way to Vp and more, then T is linearly dependent. Yeah, that's true. Okay, this span could be already a linearly dependent. We don't know. Okay, in fact, if some set of vectors span, if some vectors span a vector space, that's the smallest linearly independent set. This could be linearly independent, but this is the smallest linearly independent set. If we find a set which has more than this, that is linearly dependent. Okay. 5. The number of variables in the equation ax equals 0 equals the dimension of null A. Now that's the number of free variables, so this is false. In fact, this would have been true. The number of free variables in the equation equals dimension of null A. The only three-dimensional subspace of R3 is R3 itself. That's true. I mean, in R3 we have one-dimensional, a line passing through the origin, two-dimensional, a plane passing through the origin, and R3 is three-dimensional, and that's the only one subspace which is itself. That's true.